analyze. So, yes. Okay. This is our third and final graph you have to draw. Okay. So example 1, we have find the intercepts, describe the intervals of increase and decrease in max and min. This is a cube function. Okay. This is a cube function. It does not look a whole lot like its parent function, does it? No, not really. Cube functions are one of the, when your polynomial values start getting larger, as they change a lot from their parent function. Now, this is still the same function, it's just that its curves are more defined. It's changing, it got wider. It has intervals of increase and decrease now, right? And so that's what we're going to talk about. This is still a cube function with some very defined points. So the best way to draw a cube function is to identify your intercepts and your points of increase and decrease, okay? Nope, we're going to talk about the attributes and draw it. Ready? Yes. All right, so we're going to go over the intercepts. So step 1 is identifying your intercepts, okay? Where do you cross the X and Y axis? And you can write them as an ordered pair. You can write them as a table. I'm going to do the intercepts on a table. Is that okay? Okay, so intercepts on a table. So I'm starting from left to right. I have an X-intercept here at 1, 2, 3, 4, -4, 0. Do we see that? Yeah. I have a Y-intercept and another X-intercept here at -1, 0. My Y-intercept is here at 0, -2. And I have another X-intercept here at 2, 0. So I know that these 3 things have to be on my graph that I sketched. Does that make sense? Mm-hmm. So these are the 3 key things that have to be on my graph. Agreed? Yes? Yeah. Okay. Next, in order to sketch a graph or to identify a graph, is you have to know where it's increasing and decreasing, okay? Just like you read a book, we read increasing and decreasing from left to right. So from left to right, what is happening? Well, I'm starting over here at -infinity, and I'm going up, 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 up. So that's an increase. So I'm increasing up until this point. Okay. This point is roughly at, let's say, -2.7 and +2.7, we'll call it. 2.7, 2.8, whatever your heart tells you. So that's a point of increase. Then I keep reading my graph from left to right. And then from here to here, what is it doing? Decreasing. This is decreasing, and it decreases up until here. And this is, looks like. Oh, I'm just going to stick with 7s for today. I'm feeling it in my spirit. 7 and -2.7. So that's decreasing. And then it does what from here? Increases all the way to what? Infinity. Okay. So when it's saying to describe your intervals of increasing and decreasing, you're looking at the graph and reading it from left to right and saying what happened. So we increase from -infinity. And when you're describing, you're only using your X values because that's your independent variable, right? So we're describing it from -infinity to -2.7. That's one interval of increase. And where's my other interval of increase? 0.7 to +infinity, right? So those are my intervals of increasing. Then I have an interval of decrease. And from decreasing, again, you're only using your X values. So from -2.7 to +0.7, what is the graph doing? Decreasing. And that's how you describe the increasing and decreasing when it's not the parent function. Because our parent functions are doing what forever? Increasing, right? However, change happens. Kids act different than their parents. This is an example of when the kids act different. Okay. All right, next. It says identify your max and min from 1 to 2. When it tells you from 1 to 2, that means that's all you're looking at. So as you can see, I highlighted at x equals 1, and I highlighted at x equals 2. So just looking from between these highlights, what is my max value? My max value is 0, right? That's the highest it goes up to. Remember, we talked about before that values are your y. What is the value? And then our min value would be what? It looks like 2. We're gonna 2.5, negative 2.5. We'll roll with that. Negative 2.5. Because from the interval from 1 to 2 where I highlighted, that's all you're looking at. So from 1 to 2, what is your largest value and what is your smallest value? So my largest value is at 0 and my smallest is at negative 2.5. Okay, terrible?
No.
Do you feel confident in finding intercepts, increasing, decreasing, and max values and min value? All right. Huh? You got one to do on your own. All right, last example, but this time you have to make the graph. So we don't have our handheld calculator, so you do have to use Desmos, but I'll pull the graph up for you. So if I give you the function and there's no graph, you're like, no, miss, I don't have a graph. That's okay. Because what should you do? Use a graphing utensil, a graphing device to create one. So I'll graph it for you up here since we don't have calculators in the class. All right, so here you go. Please analyze. So you're finding intercepts. You're finding points of increase and decrease. And it asks from 0 to 2, what's your max and min? You're going to click here. You got to go to functions and scroll down. And you should see at the very bottom where it has the root with the n. And that allows you to put in whatever root you need to. Okay. So again, it's function, and you got to scroll down to number theory, click there, and now that's how you input a 3. What'd you do? Okay, let's see how we did. Show our intercepts are pretty obvious, right? So you have your x-intercept and you have your y-intercept. Okay, on our previous example, it had 3 x-intercepts and 1 y-intercept. So a cube function or a cube root function can have up to 3, right? But does it have to? No. Okay. All right. Next, then we're going to talk about the intervals of increasing or decreasing. Well, what is this graph doing? Is there any point where it decreases? No. So you only had an interval of increase. And that was from negative infinity to positive infinity because it goes forever from left to right. Then it said, where's your max and min from 0 to 2? So from 0 to 2, so at 0, we're here, and 2, we're here. So our max value is 2, y equals 2. And our min value is 1.26, y equals 1.26. And that concludes our lesson.
Nice.
Doable?
So can I just like glue it like this?
Or something? I hope. I don't know how I did. So on the cube root function, are the A, B, C, and D doing different things? No. Because has A, B, C, D changed us at all this year? No, it has not. Okay. All right. Same transformations, same rules. Only thing is different is the shape of our function, right? Questions so far? Are we ready to describe? All right. So let's jump in. Huh? Oh, don't ask him that. All right. On number 1, which variable am I given? A, B, C, or D? D. We have D equals 5. What does that mean? We go up 5. Perfect. On 2, what variable am I given? B. And what does that mean? Horizontal compression. On 3, what am I given? Your A. And your A equals negative 2/3. Ooh, what does that mean is happening? We have a reflection across what though? The X. And we have what? A compression. It's a vertical stretch. I mean, a vertical compression. I didn't mean to say stretch. It's A. So when it's 2/3, you're going inward.
Oh, okay.
So it's a vertical compression. A V compression or shrink. Because 2/3 is less than 1, right? All right, good?
Yeah.
All right, let's finish it out. On 4, what variables do I have? I have D and A. We have A equals -1 and D equals +1. So what's happening to this function? Perfect. Reflection. I don't know why I can't spell. Reflection. Across x-axis, and we went up 1. All right. 5, what do we have? C, and what is our C? -5. Our X is a liar, and our D is? So what happened? We went left 5, and we went down 2. Perfect. All right, last one. What do we have? We have an A and what is our C? +7, because our X's are liars. All right, so what happened? Good job.
That's not it. Oh, right. No,
It's a C. What else did the A do though?
Vertical.
Vertical stretch. And then we went to the right. 7. If you leave this class knowing nothing, hopefully you know how to read a transformation.
And wait,
All right.
on both of these, or-
Yeah. All right. So your classwork will be on Canvas.